Hello world and welcome to another machine learning tutorial. Today we are going to cover the topic Ensemble Learning, especially their bagging and boosting. My name is Harris and let's get started. For more tutorials and content, please hit the subscribe button or leave a like or comment there. So what are the ensemble methods? We're going to cover first of all ensemble learning, then the two methods bagging and boosting. What are the pros of ensemble learning? You're going to reduce the errors. You're going to avoid overfitting by combining a lot of predictors. You will apply the majority voting approach. And this you can do with combining many models. Ensemble learning in general, you can imagine like you have X and Y. So on the left side, you have some different data sets, and in parallel, you're going to split the data sets with randomly chosen data, and then you have, let's say, three models. Let's say logistic regression, you have a decision tree, support vector machine. You're going to apply the prediction, and then if you have, for example, dog and cat data, then you're going to predict whether it is a dog or a cat. So the two first models are going to say it's a dog, and the third model is going to say it's a cat. So because of majority voting, it will be a dog. Bootstrap regression or bagging is a similar approach. So you have basically train and test data set, which you're going to split. Then you take the training data set and you put it in, let's say, three different bags or data sets, which are going to randomly choose. And then you apply in parallel three different models, and because of a majority voting you will have, let's say, a dog or a cat. You will take the mean of it and this is your output. Boosting or adder boosting, which stands for adaptive boosting, has another approach. You can imagine it more like in series. You take a data set which is also randomly chosen, then you apply a model, and then you train the model and test it. Afterwards, you find some errors. Let's say you have only cat data, and then you find that especially white cats are going to, let's say, take application on the prediction. Therefore, you take this error pictures and you take it for the next data set. You combine model 1 and model 2 together and you start to train your model again. You test it and find out that this time not only white cats, but especially, let's say, puppies are going to apply error again. You take it to a third data set, apply a model, you combine it again with the other three models that you learned, and then you have a majority voting again. You have a nice output. So let's see how you can apply it in Python. Therefore, I first of all import the packages which are needed, especially therefore decision tree classifier, random forest classifier, bagging, adder boosting, and voting classifier. We are going to take the diabetes data set to predict whether a patient has diabetes or not. So here we can see outcome. 1 means somebody has diabetes, 0, he has no diabetes. So we are going to split the train and test data set and preview the data. We have a lot of features like blood pressure, age, etc. First of all, we are going to take the first model, which is a decision tree classifier, and then train the data set. We have a score, or we evaluate the model afterwards, and it has a score of 74%. So this is the accuracy. Afterwards, we are going to take a random forest classifier with 100 estimators. We train the model and have accuracy of 78%, which is actually an increase. Third, we are going to take the bagging classifier with only 10 estimators. We train it, and then afterwards we have a score value or accuracy of 78%, which is even better than random forest. Afterwards, we're going to apply the other boosting classifier with 10 estimators, learning rate, which you can also fine-tune kind of. A lower learning rate means it's a better prediction in most cases. Afterwards, we're going to have a prediction of or accuracy of 73%, which is a little bit lower. At the fifth step, we are going to have a voting classifier with multiple models with a logistic regression, decision tree classifier, and support vector classifier. And then we combine three of it, and then afterwards we're going to train, and we have accuracy of 76%. So in this case of this classification, we can say that random forest or the bagging approach, the bagging classifier, it's a pretty good accuracy. So yeah, thanks a lot for watching. For more content, please hit the subscribe button or leave a like or comment there. Thanks a lot and see you soon.